Hello everyone, welcome back to Dragonfly Engineering. So this week we sort of have an unscripted series of clips that my friends from GameTamer took while we were bringing up their new product that we've been working on here at Dragonfly Engineering. That's the two molds that I've been loading and setting up in the new molding machine in the background. And what they have designed and we made are these game accessories. So this red thing right here is a tray that holds dominoes or playing cards for like any number of games or just straight up card games. And then they also have this tray which holds tokens for various board games. And we've molded all sorts of different colors. There's a few other accessories like a lid for the tray, as well as a couple of other small things that connect the card rack to the tray or act as other smaller card racks as well. So take a look at our impromptu live recording of the bring up of this set of molds and debugging the processes to get good parts for production. After which we will be cranking out tons of these to sell on Amazon, or they will, under the name GameTamer. And then in future episodes, I'm actually going to show the process of making these two molds over several series. So enjoy, thanks. You're not going to see much in here.
You can get the buttons
Okay.
and everything.
Okay.
Get to save it.
So manual mode is what we're in now, which is the finger. This is setup mode, which we probably don't need to mess with too much, or at least you guys won't. And that's for setting the mold heights, and everything moves slower, but it moves without preset stops. So semi-automatic mode is one cycle. So if we have that on, but it's going to tell you everything that's wrong with the machine, so we're not ready to do that yet. This button down here is the alarm clear. Anyway, so semi-automatic mode means you hit the start button and one full mold cycle happens, including ejecting the part, and it will be sitting there open, ready to mold another one when you hit start again. And then fully automatic mode means that once you hit start, it's just going to keep making the parts until you tell it to stop, or you go back to manual mode or setup mode or semi-automatic mode. So a good tactic using this machine when it's in fully automatic mode is that you're almost never going to time it right to stop it at the end of the cycle. It's going to start the next one. But if you know that you want to stop and it's in fully automatic mode, it's better to hit semi-automatic mode. That way it's going to finish what it's doing and then be ready at the start line and just wait.
Okay.
If you hit manual mode at any point, it's going to stop instantly, and it could be, you know,
In the middle of doing something.
half of the plastic squirted in, or it's starting to open but then stops, and so it's just cleaner to do this unless something's going wrong, and then you hit stop or manual or emergency stop, or you open the door. Any of those will cause the machine to stop. The machine is a little happier if you hit this stop button or the manual as opposed to opening the door, because that like slams the machine stopped because it's a safety thing. So the whole thing will go boom, you know, if you open the door or hit the emergency stop button.
Mm-hmm.
So, but do it if there's an emergency.
Yeah.
All right, so what we're gonna do is turn on the pump motor. So this motor is basically what allows everything in the machine to move. And we're gonna turn on the heater as well. And you heard those relays click. So right now you can see up here how these are depictions of the two injection units and the heaters that heat the plastic. And it's in Fahrenheit, so the green light means that power is going to those, and we're heating the plastic up in the injection units. And since the motor is on and we're in manual mode, we can open up the mold by hitting the mold open button, which is this button right here. You can kind of see the depictions. These buttons are ejector, and sometimes it's easy to mix those up. So we're going to do mold open, and then the clamp will open up. There's your two molds. That air burst was we set up on this mold cavity to have some air jets that help knock the part off, because that's the deep part that sometimes wants to hang up on this point right here. Okay, so what we are going to do is wait for the plastic to heat up, and I will prepare some base resin and some blue color, and we'll fill the hoppers up. So these hoppers are where the plastic is ready and stored, and there's some from last night up there, and we need to keep these filled. In fact, I just got a whole plastic loading system, so automatically it'll keep adding more plastic.
How does that work?
Vacuum lines. You know, like the one on the machine up front? There's like two big system with a dryer and everything. Yeah, so that's it. Or, well, actually, so to close the mold, you gotta close this door, and then we hit the mold close button. Oh, well, that's what happens when you stop it. But I wanted to tell you, so that clunk isn't a super big deal, but try not to do it. But whenever you do a mold close, you just want to check both molds that there's no foreign objects like stuck on the mold or on this side. So you want to just get it muscle memory to check, okay, it's all clear, because if it closes, it may damage the mold.
So why did it do that clunk just now?
Because I took my finger off the button.
Okay, so you have to hold it until...
Yes.
You have to hold it until it closes. Okay.
Yeah, which is kind of a safety thing. So when you see, oh crap, there's a thing in there, you can let go and it'll stop.
Okay.
And there's like, machines like this have varying degrees of stopping. Some of them, so that probably actually decelerated a little bit, but it was still a quick stop. Where if you hit the emergency stop, it would probably clunk even harder. We are closed now. Or open. So now we're gonna close the mold after we check. And when that toggle moves completely forward, then we are fully clamped up. And this indicator right here tells you the tonnage. So there's 204 metric tons pushing your two molds together right now. And that's an actual sensor. So there's the black box in the far corner, the strain gauge, and it's measuring how much this steel shaft has stretched. And it back calculates to, there's 204 tons of force on the two molds. So when this clamp closes, the actual maintained force on the molds itself are these 4 or 5 inch steel rods stretching. So these 4 have stretched some amount, which equals 203 tons now. So I guess it relaxed a little. And then we open we inject the plastic, but then the machine will open the mold up. And then if we have to manually eject the parts, which you guys probably won't have to deal with, but just so you know, there's second injection side or second ejectors, and right now that's not lit up. So if I hit the eject forward button, then this first ejector will activate like that. And it does it 3 times and then retracts itself. When I hit the second button, now the second mold will eject when I hit the same eject button.
Okay.
And it behaves a little different, but that's it. Yep. And then over here we can move carriages forward and back. So we will move the first carriage back, like that. And every time you hit the button, it'll move back a certain amount. If you hold down the button, it'll still move, but stop at a longer certain amount, like that. And then if you want to move the second carriage back, and you don't need to know all this, just to monitor. All right, so this is the blue we're going to stick in. Blue color concentrate. And what did I say?
The cornflower blue that turns into royal blue.
Yeah.
To my dismay.
0.57 kilograms. So I hit tear. Try not to make a mess. I don't really have a little bucket. I'm not sure where that went. Gotta wait for it to stop teetering. 0.565, that should be good enough. Then plug in the ultra advanced plastic mixing system, which also turns on the ultra advanced chiller system for the building. And we dump this plastic in to mix it. This saves so much time. In the past, I would use like a pitcher of plastic at a time, and then I was like, this is ridiculous. So I stopped and went to Home Depot and got this. It doesn't totally mix uniformly though. The color still concentrates at the bottom. So probably about now we'll stop it, and then I'll dig out the color in the bottom and bring it to the top, and then run it a couple more seconds or so. Like here you can see there's a concentration of blue, like a vein of it there. Alright, so I'll hit the stop button. Actually, this makes it pretty good. It could be that, you know, this is closer weight, this color is a closer weight to the polypropylene. Piece of white. Oh, little sliver of look like white color concentration. So yeah, that's a pretty decent, just slightly more compact or higher concentration. It's also hot, so you can't hand jostle it too much. Oh wow. I'm always thinking that the thing over that. Doesn't it look like it's always about the tip? Alright, that should be enough. Still the braking down system coming soon. But for now I've got a heater up here and just lights on. And I can just barely reach to fill the second hopper. Here we go. We are loaded. Alright, so we'll see how. And usually the first 2 or 3 parts are trash anyway, and the remnant mold is removed just from cycling the 2 parts.
What do the colors mean when it was green or when it's blue?
That means when the green is on is when the heater is getting power, so it's pulse controlling. So this stage is where it'll look like I'm frenzied and stressed. So it's really, I just gotta stay ahead of the process.
All right.
So I may not talk a lot, and I may randomly run over and get something. Or
You can always dub and edit, I guess.
no, that's all right. We can time lapse it. So these two have a potential, especially when you're first starting up, of sticking. The part will stick on that side, which is a real hassle and is risky because you got to get the part out of there without damaging the mold. So I do put a shot of mold release to help release the first shot. Otherwise, basically, you stop and you spend the next half hour trying to get the part out safely, which sucks. So we're in manual mode, and with the safety guard covering the nozzle, probably won't be able to see much, but I'm going to squirt the plastic forward. Back bucket right there. Then you want to be ready on the stop button So if the mold starts to close and you still got a part hanging off of it, you want to hit stop. Otherwise,
Does that ever happen?
issues may happen. Not with these molds, because we're... And then when Big Yellow back there is set up to pull the parts, the robot will check to make sure it has all the parts in its hand, and then tell the molding machine, okay, I've got all the parts so you can go, which is the safest way to do it. Instead of a human sitting here being bored to death, because you can get tunnel vision and zone out.
How is the robot going to know that it has all the parts?
Probably light sensors. So if all the light beams are broken, then it says there's a part breaking every light, and then it'll tell the molding machine you're clear. This is going to stop. So I hit stop because we don't want to close on this. So this is the pain in the butt part.
What do you think the reason was that was stuck? And what's the
We're
problem?
just starting, and it didn't completely fill. And this may take a little bit of time, unfortunately. But we don't want to damage the mold leading edge. So this is a plastic wedge. You can stick in here. This is like cardboard, like pins on. This is like that wasn't too bad. Sometimes this takes an hour.
I see why some of those were twisted now.
Yeah, that's not wrong with that part, right?
That's a special edition. All right, close the
Okay,
door.
so I'm going to close this quickly so that we can keep going. I might plug in the mold to heat it up some more too. Okay, so as we close the mold in order to sometimes it's just a motor off. And let's hit semi out of that mode. And hopefully we'll be back to business. I might have to put some more undercuts on the back of the tray because actually the only cavity that they stick is that. So I gotta basically use a dimple. So if you're wondering why you see a little dimple deep down in there, because I'm trying to create a sticky bias. So that's the most common example of when you would hit stop. And you've got, 3 seconds to say, oh, and then hit it.
3 seconds doesn't sound like a lot.
Well, when you just start watching it, you start to know the sound.
Right.
Okay, so that one ejected off. And we are...
So, what are you doing for troubleshooting?
Go in one direction with the settings, and if it gets worse, then I go the other direction, basically. So we got little defects, look like steam bubbles. There's shred bubble marks in the corners. And then we get this subtle blush blue rainbow effect, or a halo, from injection surface feature issues. So I'm just trying different settings and trying to keep the part from sticking into the mold at the same time. But here we go. Check this one. Okay, it looks good. Yeah, the little bubbles are less, but the halo seems to be more prevalent. We still have some mold release in here from picking that last part out.
So, what was the last adjustment you made to get rid of the bubbles?
Well,
I think you said increase the pressure.
I decreased the pressure to get rid of the bubbles, but then the halo came. So now I'm attempting to, because I saw like wavefront patterns in the little halo. So now I increased the velocity of the initial shot, or the beginning of loading the plastic, to 35%, where the rest is like 10 to 15%. So we'll see what that looks like.
So this time it definitely did not stick in the mold, which is good.
Yeah, because it fully packed out. So it had the right stress profile for retention on the B side. But there's still that little rainbow, and it looks like little Saturn rings in there. But our bubbles went away. So the bubbles may have just been startup issues. Like the plastic hasn't gotten into its groove yet. I may increase the mixing of the plastic in the injection unit, mixing the blue color concentrate with the base resin, and that may help homogenize it more so that there's less chance of these bubbles nucleating, or these little defects, which are almost gone. So it may just go away by itself. So now I'm more interested in dealing with the halo. But let me increase the back pressure of the auger fill, which will help mix the color more. So we're going from 50 to 120 psi on injection unit number 1. The smaller parts just mold fine without any problems, but when we have these big surface areas, then defects that you wouldn't see with smaller features start to manifest themselves, like this halo, which may not show on the camera. But yeah, you can see distinctive rings as the flow fills the part, which is interesting in a undesirable way. And then when you make changes to the molding machine, especially mixing color, you have to wait for a few shots for the old plastic and color to cycle through the machine before you can see the effects of your new change. But yeah, you can see that predominant arc still there. But there's some bubbles there too.
Bubbles here.
I need to adjust the lighting. I've got it pointing away, but now it's dark over here, so it's hard to see. Anyway, here you go. I don't know where to stick these. These may be good.
We can look through them.
Okay. They may have a little bit of greasy on them from the shot of mold release, but you can reject them.
These are dishwasher safe anyway, right?
Yeah. In fact, I'd like to try those white ones. I have to get general authorization from April to wash parts in the dishwasher, or buy one for the shop. This is feeling warm, these parts, so I may need to increase the cooling or turn the chiller on a bit more. So, we're just debugging. Usually you try something, if it gets worse, then you just go the other direction on that setting. Unfortunately, with injection molding, you can try to be scientific, but usually you just try something. If it doesn't work, try something else. It's basically temperature, pressure, and velocity. But they're not sticking on, or they're ejecting now. Yeah, I think the halo is worse when we inject faster. It's more of an abrupt, shiny versus dull.
Gotcha.
I could let it sit in the mold, cool longer.
But then it might stick?
Maybe. But in the past, when we were trying to get rid of the blush, no matter what we did, we couldn't get rid of it. But letting it cool longer means that, the cycle time goes. Alright, so here's our polypropylene with blue. We're going to try a swirl. And then here's our polypropylene with white. Now to do. So we'll mix these together 50-50. And then in the molding machine, I'll set the back pressure for the auger to be very low so that the machine doesn't overmix these two colors, and we'll see if we get a swirl effect. So now we got blue and white. And we'll set it to mix low. think there's a little bit of blue left in the hopper. But that'll get us through the startup phase. I think it's in. Okay, let's take it in. See what we get. We're gonna go to automatic mode. Starting to get it. Yeah, I guess the question is, can we maintain an interesting pattern?
We need new footage. Go ahead and.
Oh, so here is our swirl, which is heavy on the blue right now, but we think that may be good. Like you said, the mystic look with just a little bit of a wisping of white in there. And the cycle time is less because we're not having to aggressively mix the color into the plastic as much, which is cool. You get a little starburst in the back from the gate location. So yeah, it's kind of neat. See if people like this style. Oh. Grab at the wire cutters at the base, and then pinch and roll with the curved part of the wire cutters to pull the sprue out. And that's it. And then you want to make sure that all 4 mold surfaces are clear of obstructions.
All clear.
And then if you close that door, I can do the next shot.
So, what's the fix now? What are we doing?
Well, we're getting some gouge marks from ejector pins, so we got to reduce the pressure that we inject the part into the mold with to reduce the stiction of the stress that the part is holding onto the mold. It's exceeding the ability for the ejector pins to eject it without damaging it. So I will reduce the numbers back down to what we had earlier, because the molding machine's been running for a while, so it's not as it's in its zone as opposed to a cold startup. So we can back off the injection pressure to see if we can fix the gouging from the ejector pins.
Okay.
I gotta figure out where that setting is. Mold. So we got silver streak problems with our polycarbonate parts, and we think it's residual steam bubbles in the polycarbonate when we inject into the mold. So what we're going to do is we borrowed the vacuum loader for the injection unit that we're running polycarbonate in from Chewbacca up front, the 90-ton machine, and we're going to send the vacuum loader input right into the output of our heated dryer here. So this hose basically slips onto this snorkel, for lack of a better word. So whenever the vacuum dryer, or whenever the vacuum loader needs plastic, it is going to be sucking the hottest, most desiccated plastic right out of this hot air desiccant plastic dryer. So I don't think we can get any drier than that. In fact, we set the temperature a little high and we started getting clumping of the polycarbonate pellets in the bottom hottest part of this dryer unit. So we're going to try that to get rid of our silver streak problem and our clear plastic lid. Whoop. So we changed up our design a bit. The polycarbonate lid is wrought with problems. The silver streaks we got rid of. There's also kind of a blush mark where you can see the injection pattern. But the biggest problem is this polycarbonate wasn't ejecting out of the mold very easily. And it was sticking and warping, and just generally it's too rigid of a plastic to eject out of the structure. That we evolved this lid design after a few iterations. Originally we were going to do polypropylene, but the first design of polypropylene didn't have this top rib, which aids in stacking of parts. You know, we can interlock stacking, and didn't have the cross ribs either, which are individual compartments for tokens for video or for board games. So the other thing was the original polypropylene prototype that we molded was way too flimsy, and the polycarbonate is nice and a lot more rigid. But we just had so many problems molding this, and we realized that since we added all these added rib features, we tried out the polypropylene again, and it actually ejects perfectly out of the mold, which is kind of nice. And it's a lot more rigid. The other interesting thing is, since this polypropylene is a thin wall part, the shrink factor is not the same as the thick walled same parts that are molded with the same material. So the result is, because the shrink factor of polycarbonate is much less than polypropylene, but the thin walled phenomenon of this particular part means that the polypropylene part shrinks about the same as a polycarbonate part does. So even though we're using the same mold with two different plastics with different shrink factors, miraculously this polypropylene lid fits perfectly on our trays, at least tonight. We have to see how they shrink over the next couple of days, if they do anymore. So that's cool. So let's see how a run goes. Yeah, so here's a different color of the same plastic. This is polypropylene. And originally our polycarbonate tray was designed and customized in this mold to fit on our red tray, but we're having issues where, you know, sometimes they would fall off. And we had ejecting problems. Pull these out. We're manually pulling parts out of the molding machine right now. So, with all the problems we have with the polycarbonate, we decided to just try out the original polypropylene idea. Again, like I mentioned, with all the new ribs. So now the rigidity is nice, but the polypropylene part fits on our tray exactly the same as the polycarbonate, even though the mold shrink factor between these two plastics is notably different. Polycarbonate or polypropylene shrinks about twice as much as polycarbonate, I believe. I have to look that up. Anyway, but due to the thin wall aspect of this lid, it actually shrinks half as much as its partner base, which has a much thicker wall, and it actually worked out. So it kind of got us out of a jam, because these were jamming up in the mold. Okay. And then the other thing we discovered, or we think, is the first set of trays that we molded were molded in California when it was around mid-September and it was super dry, very low humidity. But now we're in the rainy season, and the trays that we're molding now are a little bit bigger. And we think it's because of the change in the weather. Even though we're still drying the plastic the same, just the higher humidity everywhere has a subtle effect. So our press fit lid is really susceptible to little changes. So the other nice thing is this polypropylene material will stretch slightly, where the polycarbonate isn't so forgiving. So anyway, I think we are going to go back to our original idea of polypropylene lids, because it doesn't fall off. Yay!